Now we're going to look at a different method when solving quadratics, and it's called completing the square. So we're going to review a little bit of what we did last year in that when you're factoring perfect squares. So remember, this is a basic trinomial, and we could say, okay, what two numbers multiply together to give me 16, but when add together to give me 8? And that number's 4. So remember, 4 and 4 add together to give you 8. So you could say x plus 4 times x plus 4. Some of you guys would write it like this, x plus 4 squared. And that's correct. It's a perfect square. X plus 4 times x plus 4. Not a difference of square, or one's positive, one's negative, but they're both exactly the same. So this is how I want you to write those answers right here. So look at this one. This is a perfect square. The two numbers that multiply together to give me 1, and when add to be 2, it's going to be x plus 1 times x plus 1, or just x plus 1 squared. Okay? Look at over here. Two numbers would multiply together to give me a positive 81, but when add, give me a negative 18. Those numbers are negative 9 and negative 9. So I get x minus 9 squared. Look at this one. Two numbers when multiplied together to give me 25, but when combined together to give me negative 10 is negative 5 and negative 5. So instead of writing x minus 5 and x minus 5, I'm just going to do x minus 5 squared 2 times. So that's when you had a perfect square. So when you're solving quadratics and you can recognize a perfect square, that's awesome and it's easy. So watch what I do. I factor it using perfect squares. So two numbers that multiply together give me 2, add together to give me 4. Those numbers are 2 and 2. So I get x plus 2 squared equals 25. Now I can do what I did in the last lesson, which is take the square root. I can take the square root of x plus 2 squared, and I can take the square root of 25. And that gives me x plus 2 equals plus or minus 5. Okay, because it's a positive 5 and a negative 5. Now, watch what this means. When you subtract 2 on both sides, you have to do this equation 2 times, because this can be negative 5 or positive 5. So I'm going to start with the negative, and I'm going to do negative 5 minus 2 is a negative 7. When 5 is positive, I get 5 minus 2, which is 3. So my answers here are going to be negative 7 and 3. So just be careful there, because you've got to do that equation 2 times, right? Let's take a look at number 3. So number 3, I can recognize that this is a perfect square, and I get x minus 7 squared equals 4. Now that my squared term, my quadratic term is by itself, I can take the square root of both sides, and I get x minus 7 equals plus or minus 2. That's the square root of 4. You're adding 7 to both sides. So I get x equals plus or minus 2 plus 7. You have to do this equation 2 times. You have 2 separate answers, because you have negative 2 plus 7, which is a positive 5, and you have a positive 2 plus 7, which is 9. So that's what's creating those 2 separate numbers. Hopefully that's making sense. All right. Now, what happens when you don't have a perfect square? Up there, those were easy. I recognize the perfect square, and so I could do it, and then I take the square root and I solve it. No big deal. But what happens if you don't have one? You can create it. You can absolutely create it, and here's what we do. We're going to rewrite my quadratic term if it's given to us in standard form, and we're going to put the c value on the right-hand side. So that gives me x squared plus 8x equals negative 7. And I leave myself some space here because I'm going to create this third term. And how do I do it? I take half of this 8, which is 4, and I square it. 4 squared is 16. So I'm halving 8, and then I'm squaring it, right? So I get x squared plus 8x plus 16. That's how I'm getting 16. Because I'm halving it, 8 divided by 2 is 4, 4 squared is 16. And remember equality. Whatever you do to one side, you do to the other side. So if you added 16 here, you better add 16 over here. And then I can simplify this to really be a positive 9. Okay, when I add 16, so I can get positive 9. Now, I have created a perfect square, and I can just do what I did up above. What two numbers multiply together to give me 16 and add together to give me 8? That number's 4. So x plus 4 squared equals 9. And then I take the square root, just like I did before, and I get x plus 4 equals plus or minus 3, because that's the square root of 9, plus or minus 3. Subtract 4 on both sides, and remember when you do that, you've got two things going on here, two numbers. You've got negative 3 minus 4, which is a negative 7, and you have positive 3 minus 4, which is a negative 1, and then of course you put it in brackets, least to greatest. Okay, so the only difference here is that we're creating this third term and adding it to this side. So let's do a couple of examples together. All right, let's take a look at number 7 and 8. Let's do 7 and 8. All right. This is not a perfect square. It's not even set up right. So I'm going to keep my constant terms to the right and take my linear terms to the left. So I'm going to subtract 18x, and I'm going to subtract 71. 1, and then so I get x squared minus 18x equals negative 80. So I brought my constant terms to the right and my linear terms to the left, and that's what I have. Now, I'm going to leave myself some space because I'm going to create that third term. So I get x squared minus 18x plus something equals negative 80. And remember how I find that plus something, that constant term. I take the linear term, negative 18, I divide it by 2, which is negative 9, and negative 9 squared is a positive 81, right? So negative 18 divided by 2, which is negative 9, and then negative 9 squared is 81. So divide by 2 and square it. Whatever you do on one side, you do on the other side. And this becomes positive 1. So I get x squared minus 18x plus 81 equals 1. Now I can do that perfect square. So two numbers that multiply together give me 81, and add together to give me negative 18 is negative 9. So x minus 9 squared equals 1. And again, what do I do here? I take the square root of both sides. So I get x minus 9 equals plus or minus 1. Now I'm going to add 9 on both sides, and I get two answers here. I get a negative 1 plus 9, which is 8, and I get a 1 plus 9, which is 10. And that gives me the answers of 8 and 10. Let's try number 8. We're going to get constant terms on the right-hand side, so I'm going to add 50 to both sides. I get x squared plus 2x plus something is going to equal 50 and a negative 2, which is 48. Now to get this third term, I take my linear term 2, I divide it in half, which is 1. 1 squared is 1. So I'm getting 1, and whatever you do to one side, you do to the other side. Now I can factor this perfect square, and I get x plus 1 squared equals 49. And now I just do what I've been doing. I square root, and I get x plus 1 equals plus or minus 7. When I subtract 1 on both sides, you have two separate answers. You get a negative 7 minus 1, which is a negative 8, and you get a 7 minus 1, which is 6, and put brackets around least to greatest numbers don't repeat. Okay? All right, let's look what happens when you have an irrational solution. Well, it's the same thing. You've done it. We've been doing it. I'm just going to give you two examples. So let's take a look at number 10. Same thing, constant terms on the right-hand side, plus 16x plus something equals negative 46. I just subtract 46 on both sides. I'm creating this third term, so I'm going to divide 16 by 2, which is 8. 8 squared is 64. Whatever you do one side, you do the other side. So now I have x squared plus 16x plus 64 is going to be equal to 18. I'm going to factor this square, which is x plus 8 squared equals 18. Now I'm going to take the square root, and I get x plus 8 equals, you've got to simplify this. So if you simplify square root of 18, I get 2 and 9, 3 and 3. So I can take a 3 out, and I have plus or minus 3 square root of 2. With me? And now I just subtract 8. So my final answer is going to be, and I would do negative 3 square root of 2 minus 8 and 3 square root of 2 minus 8, because this tells me I have two separate solutions, right? I can't simplify these guys together because they don't have a square root of 2 in common, so I keep them separated just like that. Let's try one last one, number 12, okay? So again, I want my constant terms on the right, linear terms on the left. So I'm going to subtract 6x, and I get x squared minus 6x. I'm going to add 2 on both sides to get that constant term to the other side, and I get negative 1. That's what happens when we rearrange it. I'm going to create this term, so negative 6 divided by 2 is negative 3. Negative 3 squared is positive 9. Whatever you do to one side, you do to the other side. And this becomes x squared minus 6x plus 9 equals 8. I'm going to factor this. So x minus 3, two numbers multiplied together give me 9, combined together give me negative 6 is negative 3, squared equals 8. And then I simplify by taking the square root. X minus 3 equals, I must simplify 8. So I get 4 and 2, 2 and 2. So this simplified is plus or minus 2 square roots of 2. It took one pair of 2's to come outside, and then you have a 2 left over in the box, remembering that it can be plus or minus. So now you're going to add 3 to both sides. And you have two separate things going on here. You've got this negative 2 square roots of 2 plus 3, and you have this positive 2 square roots of 2 plus 3. And those will be my answer. So that's completing the square. If you're struggling, come and see me.